and you can assign it x or y, or a variable based on what the problem is asking. So if it said length and width, what would you use? Would you use x and y? Or would you use L and W? L and W. If it said depth and width, what would you use?
E and W.
If I said shoes and purses, what would you use? Okay. All right, and then it says write equations that you know based on the scenario. Put both equations together inside a bracket and solve for the specific answer. Now, this is what's going to help you with your assignment that's going to be due Wednesday. So at the end of the class period, you're going to get a packet, and you're going to have to create systems on your own. So I highly suggest that you go back and watch this video, because I'm not going to leave this up here. We have other stuff we have to do. Today, we're going to talk about the different types of solutions, which we've already seen in our work that we've done with graphing, with substitution, and elimination. So this is 38A. Our learning target for today says I can determine the type of solution to a system. So we have one solution, and that's where your lines cross or you get an exact point. We have no solution, where they don't cross at all. They never touch their parallel lines. And then we have infinite solutions, and we're going to talk about what those look like. Okay. All right, how many ways do we have to solve a system? 3. Take a point. What are the ways? Name one. Elimination and substitution. Awesome. Both of you take a point. What's it? The last one? Graphing. Take a point. So what we're going to do is we're going to take this guy and we're going to graph it. I'm going to do this first one in pink. I'm going to do this guy in orange. Are we ready? Is anybody alive?
Yes.
Are we alive out there? Alright, so how would I graph this guy? The first one.
Up 3.
Up 3. Awesome. And then what do I do?
Up 4. Right 1.
Right 1. Take a point. Up 1, 2, 3. Oh, I don't have enough room there. So if I don't have enough room to go up 4 and right 1, what do I do?
Down 4.
Look at you guys go. It's like you've learned something. 1, 2, 3, 4. Left 1. Down 1, 2, 3, 4. Left 1. Now, why did we go down and to the left?
There was no room up.
Uh-huh. And we have what kind of slope? A positive. So our line has to be climbing the hill. Now remember, when we are graphing, they have to be in slope-intercept form, correct?
Yes.
Is this guy in slope-intercept form?
No.
So what do I have to do?
You would take X.
Look at you guys go. I'm so proud of you. Like, I really am. I don't want you to think I'm being sarcastic. I'm sorry. I don't know how else to sound. Alright. Alright,
Down 2.
the wheels just spin. You go down 2 and put a dot, and then what's our slope?
Down 1.
Down 1, right 1.
Down 1, right 1. Are we ever going to cross if we keep going down 1, right 1? So what do we do?
Up 1, left 1.
Woo! It's -1, -1. Oh my gosh. That's a miracle. It's a miracle. Because we found it. We found it with minimal struggle. So that's exciting. For once. Alright, so we solved by graphing. Now we're going to solve the same system by substitution. So what I want you to do is please rewrite the system right here. Y equals 4x plus 3 and x plus y equals negative 2. Now these next 3 pages are also going to, or next, this page and the 2 after, are going to be good practice on how to turn it into using whatever method you want to use. So for this one, at first, we solved this for y so that we could graph it. Now we're going to use substitution. Now, do we have to do anything to either equation to use substitution? No, not this time. Because we have y by itself, correct? So we're going to take what y equals and we're going to plug it in right here. Is everybody with me? Is anybody not with me? Yeah.
Is that a 2? Why?
Yeah, I just rewrote the equation, guys. We have the equations right here.
I wrote a 3.
I just rewrote them.
Oh,
So even if you can't read my handwriting, we're still using the same system.
X plus y.
It's crazy. Did you put negative 3? I had no idea.
Well, now you do.
Alright, so now I'm going to plug 4x plus 3 in for y because this is y equals. So I'm going to write x plus, what does y equal? Take a point over there. Alright, now what do I do from here? Yes, take a point. Remember, today's the day that you can go over. So I add the x, and that saved some of you last week, just to let you know.
Yeah.
Alright, so that gives you, come on, pink marker, don't die. 5x plus 3 equals negative 2. Alright, who can raise their hand and not scream at me and tell me what to do from here? No, all 4 of you have already answered. Put your hands down. No, all 4 of you have answered. Alright, Curtis. Subtract 3, take a point.
See, that's why I raised my hand.
I love that you guys really want your points and want to answer, but y'all been rocking it.
That's what we're going to tell you. Let us.
Yeah.
Yes, I'm going to let you fail. That's exactly what's going to happen. Because I never give you multiple opportunities to do anything. Alright, so x equals negative 1. Do we agree or disagree?
Agree.
Agree! Now that we have x equals negative 1, how do we find y?
Plug it in.
Plug it in where?
In the other equation.
Woo!
Get a point.
Get a point! If you said plug it into the first equation, get a point.
I said it. I did for.
Okay. Alright, so now we have y equals 4. What does x equal? Times negative 1. Come on, Blair. Plus 3. And then what's 4 times negative 1? And what's negative 4 plus 3? Is that what we found our solution to be in the beginning?
Yeah.
Boom, we did it right. Question so far. Are we alive?
Yes.
Yes.
Are we sure?
No.
No? Do we understand what's happening even if we're dead and zombies?
Yes.
Okay, that's all that matters. As long as my zombies are learning, I'm fine. Alright, so now what we're going to do for elimination is we're going to have to fiddle with these. Now, to use elimination, remember you need your x's on top of each other and your y's are on top of each other. So this bottom one, let's write it right here. But I need to move my top one. I need to fix something. So how can I get it so that my x's and y's are on top of each other? Minus 4x, take a point. So I'm going to have negative 4x plus y equals 3. Okay, so my first equation was y equals 4x plus 3, correct? Now, I want to have my x and y on the same side because my x and y are on the same side here. So I would subtract 4x, and that would give me negative 4x plus y equals 3. So that's how we got that. Yes, no, maybe?
Oh, yes.
Okay. Alright, now, our y's are on top of each other, our x's are on top of each other. We can eliminate our y's using what? Subtraction. Take a point. Now, they have the same coefficient of 1, and the same sign, so we subtract. What's negative 4x minus 1x? Yes. All right, what's y minus y?
Y.
There.
No,
Zero. It cancels. It dies. What's what's 3 minus a negative 2? 5. X equals negative 1. Now, could we plug it into the top, the bottom, or the original one over here? Whatever. They're all the same thing, right? So pick whichever one you want to plug it into. I don't care. I'm not going to write anything down until y'all have written it down. You have to be able to do stuff without me. Put it this way. Did y'all get negative 1 still? Woo! Did anybody plug it into a different one than I did? I plugged it into the bottom. What did you plug it into? The very top one?
Me too.
And you did negative 4 times a negative 1, and you got positive 4, and then you subtracted, and you still got y equals negative 1. Yes. Questions on one solution? Are we ready to see what no solution looks like? This is 38B, as in potato. Now, a great way to tell if a system is going to have no solution is if they have the same slope and different y-intercepts. So same slope, different y-intercepts, no solution. So I'm going to graph this first one in green. And I'm going to graph this one in red. Y'all ready? They are, because they have the same what? Look at you go. Jeremiah, do you need to stand up and do some jumping jacks, son? Okay. All right, what's our y-intercept?
4.
Please put a dot. Add 4. What do I do from there?
You go up one, right one.
Which way? Take a point. Up 1, right 1, up 1, right 1. You can also go down 1, left 1, down 1, left 1. How many dots do you need to have? At least 3. We're going to do some tomorrow where you have to go all the way across. But it's going to be so much fun because it's going to look beautiful. Get excited. Do you? Look at you guys go. It's like I've taught you something. It's so exciting.
You taught me how to kill someone.
Whoa, it's recording.
Oh, hello there.
All right, what is our... What is this y-intercept?
You go down 1.
Down 1, and then?
Up 1, over 1. Or right
Up
1.
one, right one.
Up 1, right 1. If you said up 1, right 1, take a point. How many points do we need to have?
Oh,
At least 3. Take a point. Boom, they're parallel. They're no solution. Easy peasy lemon squeezy. What's wrong with you? We're almost done. We really are. And then you get your assignment, and it's, yeah, you just put a book together and you answer the questions. Yeah. I think I may let y'all do infinite solutions for homework so that we can talk about the booklet. And your booklet isn't due until Wednesday, so there's all kinds of time for you to do it. Because I'm so tired of talking about systems of equations. Like, I'm ready for the next section. It's exponents. It's going to be awesome.
oh, I was going to
Oh, I know. It's going to be so much fun. All right, substitution. Blessings, my child. Oh, blessings, my other child. Are y'all allergic to me? Yes. Stop it. No. Alright, so, substitution means that we need a variable by itself. Now, do we have a variable by itself? Which one? Y. And that means that we're going to take this, our Oreo, and we're going to plug it in right there. So when we write it, am I not entertaining you?
No. I think it's alright.
And then we're going to say x plus 4 equals x minus 1. What would we do from here? There. Subtract x. Take a point. And they cancel on both sides, and you're left with 4 equals negative 1. Is that a true statement? No. No solution. No, I don't mean to write a 0. No solution. This one is also no solution. Questions? But what word did you say? Okay. Alright, so on this one, remember we need to have x and y on the same side. So how would we move this x over here? Subtract. So it would become negative x plus y equals 4. How would we move this x over here? Negative x plus y equals negative 1. Now, both of those have the same sign. So they have the same sign, same coefficient. How do we cancel? But what operation?
Oh, add.
Nope. Opposite signs add, same sign. Subtract. Take a point. Well, I really can't hear you.
I said subtract.
Okay, then take a point.
I said subtract.
You didn't. He did.
Subtract.
Oh, okay.
Alright, negative 1 minus a negative 1 cancels. 1 minus 1 cancels, so we have 0. 4 minus a negative 1 equals 5. Does 0 equal 5? No. No solution. Alright. One solution, the graphs cross, and we get a point as our answer, correct? Yes. Where it says solution, what's your solution? So what are you going to write right there? No solution. No solution. Alright, one solution crosses at a point, you get numbers as your answer. No solution, the lines are what?
They don't cross.
Did you say pillow? Oh, I'm so sorry. Parallel, they don't cross, they have the same what? So, take a point. Alright, and when we plug it in, we don't get the same answer. So, one solution crosses, no solution doesn't cross. What is infinite solution going to look like? They're the same thing. They're going to be right on top of each other. So, we're going to do this first part together. We're going to graph together, and then tonight you're going to substitute and eliminate without me. This is 38C. Alright, I'm going to graph this top one in blue, the bottom one in orange. Can someone please help me graph this one?
Go up 1, down 3, left 1.
Wait.
Up 1.
And then down 1, 2, 3, left 1. Down 1, 2, 3. Oh, wait. I was supposed to go down and to the right because it's negative.
I said right, but I thought I was wrong, so that's why I went with you.
And then up and to the left. That's okay. I didn't catch it either. Bam. Sometimes you just have to get excited. Like, it's not always lots of fun, but you have to make it exciting. I don't know what you just said. Okay. Alright, how do we solve this guy for y?
Subtract 6.
Subtract
From both
6x.
sides. Oh, you do it.
And you get 2y equals negative 6x plus 2. Now what do I... Divide by 2. Do I divide one thing by 2 or everything?
Everything.
Everything. What is negative 6x divided by 2? Take a point. What is 2 divided by 2? Take a point if you said 1. How do I graph this?
Go up 1, down 3.
Is it the same line?
Yes.
Look at us go. So, no, well, I'll let you finish that. I'll pause. I get excited. So, no solution. We had different numbers on the sides of the equal sign. What will we get for infinite solution?
The same number.
The same number. Take a point. So, I want you to solve this by substitution while I'm passing out your paper. Do y'all want orange or green?
Green.
Green.
Okay, I'll do that. So, do substitution and elimination now as you're grouping. You have to cut on this line right here. The second line you're going to cut. Okay? So, it's going to look like I'm going to cut the bottom right beside 3. And I'm going to cut straight up. No, I just said 4 times to not cut all at once. Okay? So I've cut it. Then I'm going to cut on this line right here. So I have squares. Now, do you see in the bottom right-hand corner how we have page numbers?
Yep.
You're going to have to put this in page number order. It is. It's a book. Yes. I'm sorry? There's some in the top drawer of your tower that I'm looking at right now. Alright, so once you've cut out all of your pages, you're going to need to cut out all of them. Cut out the square. Do not cut off this edge. 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 You need it. Do not cut off this edge. You need it. They will stack on each other so you can actually open it up and see things. And then put it in number order. So let's work on that right now.
Got it. So we cut off.